Hey guys, welcome to Code Decode. Today in this video, we'll be looking into the ways how to replicate your DB instances across multiple nodes. Why do we need to do that? Why is it really necessary? What if we don't do it? How will you handle the availability, scalability? If we do it, how to do it synchronously or asynchronously? If you do it asynchronously, how to handle lags and how to handle the several concurrent writes and what consistency model you should use and in which particular scenario. So to see all those scenarios, let's get started and see how to solve all these issues. Please like, share, subscribe and comment so that this video reaches to more of the people who are preparing for interviews like you. So first of all, why replication is needed for the database? Coming to this, you have a front-end application, you have a corresponding back-end application and you have a database connectivity. Suppose you have properly configured your application, your backend is properly scalable, load balanced, rate limited and everything you have done to make sure your application is up and running all the time. But you have kept only one single instance of DB on one server node. Now what if this particular database server crashes? Even though you have made sure with your front-end and back-end technology that your application must be up and running all the time, your availability is affected just because your one database instance got down. So this is a very bad habit to have just one single instance of database deployed. Because it not only affects the availability but also affects the performance. What if the calls to database increases a lot? Then only one single server will not be able to handle all your requests at one point of time and will give you delays to the front end and to the client at the end. So this is a very bad technique to have only one single instance. To prevent such kind of crashes, delays in performance, availability issues, you should always replicate your DB instances on multiple servers or nodes. In the previous video, we have seen how to choose the best database. If it is read intensive, if it is write intensive application, if it is transactional based application, if it has to follow ACID properties, in all such scenarios, which database, NoSQL, SQL, in which NoSQL you need to have graph database, which database has to be used. All of those things we have seen in the previous video. In this video, we will be seeing that, okay, now you have the best database you have chosen for your application. But out of this best database, how to replicate it so that you can maintain the availability and increase the performance by reducing the delays in reply to the client. So if you have deployed only one instance, it might fail and crash. So isn't your availability affected? Isn't your application down just because you have one server or one node for the data? Yes. Now what you need to do to prevent such failures? Shouldn't we replicate the instances to multiple nodes and servers, and hence data replication is needed. Now what is data replication? Replication is used to store multiple copies of the same data at separate nodes. So you would come to me and say, oh, why are you wasting that much space by saving the same copy of data scattered across globally in different data centers? The reason I would say is that it prevents you from crashes, from unseen events. Like if it crashes, your whole application is down. So all your hard work that you have done to prevent your application to be down for your customers, you are failing at some point of time because you have not considered the replication factor in your mind. So to achieve your whole application's availability, scalability and greater performance by reducing the delays, when n number of requests comes, when you segregate it to n number of nodes and all the nodes reply at the same time to client, your performance, your delays reduces, your performance increases. So that is why replication is needed. But replication doesn't come that easily. It comes with complexities. You have multiple database instances. Now what will happen if backend says update the employee 1 from name code to name decode? Now that has to be done across all different servers that you have created. So this has to interact with this has to interact with this, and this increases the chances that if a backend application directly hits this before it is written, it will read the stale data. So this is the problem that occurs when you have multiple database instances writing asynchronously and anybody trying to hit it getting the stale data because of concurrent writes. So yes, if the copied data doesn't require frequent updates, you just need to read it. There is no write. There is no this frequent updates is required. Then if you read from here or you read from here, it is okay because anyways there is not much of the write operation. Hence it is all the three database data is always synchronized. So replication becomes very easy when frequent writes is not there. Replication is easy when you have read intensive application. But when you have write intensive application, that means clients usually updates their data frequently then replication becomes the main issue, and that's where main models comes into picture to maintain your concurrency and your trade issues. So what are the complications? How to maintain consistency across multiple data. So this is also one of the note. How to maintain the consistency. How to replace the failed replica. So suppose if this replica failed, how to redirect it to the another database instance so that your application becomes available all the time and it doesn't give you 500 internal server error, database is down, sorry. How to do that? Then if you say that yes, I need replication in my application, the next question interview will ask you, will you do it synchronously or asynchronously? So what is synchronous and asynchronous, we will be seeing in the next few slides. Now if you go for asynchronous, how to handle lags, we will see that also in next upcoming slides. Then if there are several concurrent writes, how to manage them, and which model will you use at the end depending upon your application, write intensive, read intensive. So let's see all of them in detail now. What are the ways to replicate across multiple nodes? So the two ways that I have shown you is synchronous and asynchronous. Synchronous is this kind of model where there is a primary node. Here in this case, it was the primary node and all the other were the secondary nodes. And it was the task of this primary node to update all the secondary nodes and wait until they get acknowledged, yes, I have updated my old stale data, and now if backend hits me, I will have the updated data only. This is synchronous, and then only primary will say to backend, yes, we have all the instances updated, we have updated everything, you can query anytime and you will not get the stale data. So it will wait for acknowledgement, that is synchronous. When it doesn't wait for any acknowledgement and just give the update event to all the secondary nodes and directly update the backend that yes, we have updated. It doesn't wait for any of the secondary node to give the reply back that they have updated the data or not. That is asynchronous communication. So the only difference between synchronous and asynchronous communication is this acknowledgement part. Unless you will not get acknowledgement from all the three nodes, the backend will not know that yes, you have updated your data. Even though you have updated in the primary, the secondaries if not updated, you will not get the acknowledgement to the primary, and primary will not say to the backend, okay, we have updated, thank you for the update. While in the case of asynchronous, as soon as backend updates or give a read or write request to primary, the primary updates and gives a write request to secondary and leaves it there. And then says, you go and update it how you want to, if you want to, if you don't want to, if you're crashed, that is also not my problem. It will say to the backend, yes, I have updated my data. They will update later on, you can go ahead. But this will lead to the stale data. You'll say, okay, then synchronous is better. But there is a problem with synchronous. That is, if one of the nodes died, it will not be able to give you any acknowledgement. If no acknowledgement comes, even if your both the secondary which is healthy and your primary which is healthy is updated, you will not be able to give response to your backend that yes, I am updated, you can read from me, we don't have stale data. You cannot do that just because of one of the crashed node. So if there is a crashed node, your synchronous update will fail, and hence async comes into picture when even if your secondary dies, still the primary and the active secondaries have the data and they will not stop any kind of read request from any of the up and running secondary or primary instances, database instances. So they both have their advantages, they both have their disadvantages. Let's go to the theory. So synchronous replication involves primary node, this node waiting for subsequent nodes or the secondary nodes to acknowledge that they have updated the data. The principal node or this primary node notifies the client of the success only after getting acknowledgement from all the secondary. Until all the secondary doesn't give acknowledgement, the primary will not update your client that yes, the write or update is successful. While in asynchronous communication, the only difference is of this acknowledgement. The primary node updates itself and announces it to the client that yes, your write is successful. It doesn't wait for any of the secondary node to acknowledge that yes, they have also written it to their respective database instances. That's asynchronous. Now synchronous has a benefit that they are completely in sync. You will never have the stale data. But there is a drawback that if any of the node dies or fails or crashes, the primary will not able to send the acknowledgement to client until the crash node is up and running again and is able to update itself. So that is the delay which is a problem, and it is a large delay and the response to the client is delayed and which decreases the performance. Hence, if it is not that much necessary to have all the nodes updated at the same time and not to have stale data at any possible condition, then go for synchronous. Else always go for asynchronous communication. In asynchronous, primary node keep on working even if all the nodes are down. In this case, delays are very less because client as soon as updates the primary node gets yes it is updated and can go on and perform. So this is a very beautiful performance. It's a high performance. But there is a risk of equally having inconsistency or stale data. So this is a trade-off between the delay and the inconsistency. So if performance you need high, you might have inconsistency. But if you need consistency at any cost, then performance delays are bound to happen. So you need to choose, you are okay to have less performance or you are okay to have a stale data. I'll give you an example. If you have a book my show type of application, the stale data is not possible because if a seat is booked, that is to be booked across all the nodes. Otherwise, you will end up selling one seat of the movie to multiple people, which will lead to a chaos at the movie hall. So not to do that, in that case, we need consistency at any cost. But if you are just storing some data like country or state information where read is a lot but write is very less, and you need a quick drop down update for selecting the country, you need to have all the states. For selecting a state, you need to have all the countries. Your performance is really important. Your client will not keep on waiting for drop down to fill. Your delays are not allowed. In that case, you can always go for async communication. Now, if you know when to use what, we will see some models as to how to replicate. So this was very high overview of how it is done. But in reality, we have few models. It's not necessary there is only one primary node. There can be multiple primary nodes also to prevent single point of failure. That is called as multi-leader. You can also have all the nodes as the primary nodes. That is peer-to-peer or leaderless replication model. So basically you have three types of replication model. The single leader or this one that we have seen. One primary and one primary updating all the secondary. Secondly, you have multi-leader. And why does it come into picture? Because single leader has single point of failure. If this single leader fails, all your secondary nodes will also not have the updated data and will remain with the stale data. So this is single point of failure. Hence comes the multiple primary nodes. This is multi-leader. You have two leaders here. Both of the leaders will get the right update and both of these leaders will have their own set of secondary nodes which they will update. If in case one of the primary dies, all the write request comes to here and all the write request will come from second primary node for these two instances also. There is the third one, that is peer-to-peer. Here all of the nodes are leaders. Here only one leader, here were almost two leaders, that is multi-leader. Here everyone is a leader, there is leaderless. Everybody is capable to take the read or write request and everybody passes this read and write request to each other. So these both prevent single point of failure. That was an issue from the single leader model. So the replication models are single, multi-leader and peer-to-peer. We will also see how to implement this in reality using the statement-based, wall and logic-based logs. We will see what are all these with the theory now. So we have seen a single leader application. One node is assigned as primary and it is in charge of handling all the writes to all the secondary nodes. When to use this and when not to use this. When your workload is read heavy, this is the perfect strategy because write is very less. So it is a very less time this primary has to update the secondaries. Since it is read heavy application, you can read any of these instances. But if your workload is write intensive, that means primary has to do lot of work. It has to continuously ping each and every secondary that please update, and in the case it fails, it becomes a single point of failure. So if the primary node fails, unable to propagate new data to the secondary nodes, client reading from various copies may encounter the stale or inconsistent data. So this is a disadvantage of it. But there is one advantage also. So if it is read intensive application, if your primary node fails, your read request will not fail. Why? Because read can still be processed with another secondary nodes which are up and running. So read request will not fail, but write request will fail. So that is why it is said that primary and secondary is very good when you have read intensive application, but not the write intensive application, because your read intensive application will keep on reading from the secondary which is still up and running even if your primary dies. But if your primary dies and if it is your write intensive application, you keep on writing to primary which is down and you will have stale data at secondaries from where you will read, which is healthy one. How to achieve it in real time we will see after we have seen the multi-leader and the peer-to-peer. The disadvantage of single leader was the single point of failure. So to prevent that single point of failure, single leader replication model can be substituted by multi-leader replication model. The write request is processed by several primary nodes, which is then sent to other secondary and primary nodes. So here in multi-leader model, you have multiple leaders, and all the write application not goes to one single primary but to both, and it is a task of both of these primary nodes to give it to secondary. Now since this is not a single point of failure, if one dies, all the write request will be updated to other secondary using the second primary also. Though you can see that yes, multi-leader is very good. It is much better than single leader, but still it has some problem associated with it. The problem of concurrent write request. So the issue of concurrent writes were not in primary and secondary model. Why? Because there is only one primary and all the secondary gets the write request from only one primary. But when it comes to multi-leader, there are multiple primary nodes who have the write request and who can forward it to secondary multiple times. So n number of leaders, n number of times secondary can get the write request. Now it will lead to conflict because primary 1 will say updated to plus 10. Second primary might also say updated to plus 10. If it takes both of them, it will add a 10 plus 10, it will increase by 20. So which is a problem. That is a conflict. This same conflict issue will also come in another model also, peer-to-peer or the leaderless model. We will see what is peer-to-peer or leaderless model. Here we had one leader, that is primary. Here we had multiple leaders, that is in our case there were two leaders, two primary nodes and multiple secondary nodes. So this is multi-leader. But when we don't have any leader, everyone is a leader. That is leaderless model or peer-to-peer model. So here all the three nodes are capable enough to take any kind of read or write request. So all the three nodes can have read and write request like this. This is peer-to-peer model. This also has the same problem. So primary node has a bottleneck of single point of failure. So this removes the bottleneck. So if even one peer goes down, other two is capable enough to even take a read request, also take a write request and update among themselves. Also it supports scalability because they all can have the read request also. That is why multiple read requests comes together. Then they can divide it among all of them and have lesser delay and get greater performance. So that is read scalable. So each node is equally weighted and is capable to accept both read and write request. This is a design which is actually made popular by Amazon's DynamoDB. But again, this has the same disadvantage, that is concurrent write. So what happens if all the three have the concurrent writes? They pass it among themselves and they might have conflict. Same as we have with multi-leader. It has the write update from the primary node 1 and primary node 2. Then what will happen? Conflict will happen. Similarly, this peer can have the write request from this peer and this peer also, and also from the client. So it's multiple ways it is getting the concurrent write request. So this is even worse than the multi-leader model. There are ways to avoid these conflicts and concurrent writes. These are to prevent it from the first place only. That is, make sure that the set of secondary have the same leader. So what you can make sure that these two secondary will have this leader, these two secondary will have this leader. So this is one of the ways you can prevent the conflict in the multi-leader model, which cannot be implemented with peer-to-peer. So what I always prefer is to have the multi-leader model. Here you have multiple leaders, so even if one fails, your availability is still not down. Your write request will be captured by this primary one and will be given to all the secondary ones, and read request will be given to all the 5 of these nodes. Hence, it's read scalable, and write doesn't also have much of the issues on the single node since it is multi-leader. Also, you can have the last written commit to have the timestamp. So what happens is, if this also sends the request to secondary, this also sends the request to secondary, the one which is coming the latest can be taken as the latest update and can be taken using the timestamp. These are ways to avoid the conflict. The best way I feel is to divide these secondaries into zones in the data center and only make one leader who is updating these secondary. In case of failure, then go to the second one and make them as a subset of this primary. If this is failed, then only. Otherwise, have a clear segregation of the leaders. This was all theoretical, but how do we do it in real time? I'll take an example of single leader or primary secondary. So there is one primary, multiple secondary. How do you actually update all these secondaries? So you update it, but how do you really update in the real time? That's the real question. So these are the 3 types: statement based, wall and logic row based logs. use the statement based. That means if it is update statement, it says update employee name as Decode where employee ID is 1. Then what it will do, it will update initially in itself, and as soon as it updates it, it will forward this insert or update statement to other secondary, and then secondary also says, okay, I have to update the employee name to Decode where the employee is 1, and similarly this also will do. So this is statement based update. The second one is wall, that is write ahead log. Why did this come? If there was already a statement based replication, the statement based are initially saved and then sent to secondary node for processing. But now if my update statement says update your employee name as Decode and updated data as now where ID is 1. So this now is a function that is going to have the different values. When it reaches to primary, it will have now as 201. But when it is sent to secondary, it might have 202. Then the updated value in primary and secondary are different. The updated value for primary is 01, updated value for secondary is 02, which is a different values. They are not in sync. So that can be a problem with statement based replication. But it is okay. In some scenarios, it is okay to have the updated time. It shows the real updated time. It is okay in many cases. But in some cases, you cannot allow it. In that case, statement based update is not a real time scenario. In that case, you can also use the write ahead log. What does write ahead log do? I'll tell you. First, understand how rollback works in a traditional database. So there is one file. Whenever you update something, you keep the original copy in some file or the rollback journal and change the database. So now your database is updated, but in case of crash or rollback, the journal having the original data is copied to the updated database and updated database data is thrown away. That is how rollback works, right? You have a journal, you have the existing stable data into it, update the database. If rollback has to happen, go back to the journal, get the stable data back into the database. The exact opposite of this is write ahead log. It says that original content is in database. All the changes that you want to do has to be done in a file or a journal called as write ahead log file. Now what happens here is you have a write ahead log created. So as soon as client sends request to wall. So you need to update the name as Decode where employee is 1. That log is created in this log file. And this log file is then simultaneously sent to primary and secondary together. So this is write ahead, and all the changes that has to be done is added in this log, and the same log has to be added to both all of these. And the last way to replicate this change to secondary is the row based replication. Here what happens is the actual data, not the query, not the log, the actual data is replicated across the secondary nodes. For instance, is a new row added in the primary. So add new row or update some row. That data comes into the primary node. Exact data is copied into the secondary one rather than any kind of statement or logs. So it is just a duplicate change that is done by secondary from the primary, and that too at the record level. So whatever is your database, whatever is your engine, it doesn't matter. The whole data is copied from primary to all the secondary. There is no challenge for data architecture, database engine, it doesn't matter, because the very atomic level data or the row is copied from primary to secondary. So there were 3 ways to replicate data from primary to secondary. These were statement, transfer the statement. Second is the wall based, that is a log is maintained and that log is updated to all the 3 of nodes. And the last one, the row update. So primary updates the rows and the data is as it is copied to secondary. Neither the statement nor the logs has to be transferred. The complete raw data is transferred to the secondary. So this completes our replication models, types of replication models, and the real-time way in how actually we can update the secondary from the primary ones. Next, I have to cover the data partitioning, shredding, how to do that. If you have a very big database, how to actually shred it into multiple different shreds, the vertical and horizontal shreds. That I have to cover. So multiple things are still remaining. If you want me to cover that, just let me know in the comment section. I'll create more videos on data partition, data shredding and all those concepts. Thank you.